Good day everyone, I am Eunice Grace G. Mercado from BS Ed Math 3. Today, we are going to tackle Math 25 Module 3, Lesson 3, which is testing the difference between two means under the dependent sample. To begin with, let's recall that in Lesson 2, the t-test was used to compare two sample means when the sample means were independent. However, in this lesson, a different version of the t-test is explained. This version is used when the samples are dependent. Samples are considered to be dependent samples when the subjects are paired or matched in some way. To illustrate, suppose a medical researcher wants to see whether a drug will affect the reaction time of its users. To test this hypothesis, the researcher must pre-test the subject in a sample first. That is, they are given a test to ascertain their normal reaction times. Then, after taking the drug, the subjects are tested again using a post-test. Finally, the means of the two tests are compared to see whether there is a difference. Since the same subject is used in both cases, the sample is related, and subjects scoring high on the pre-test will generally score high on the post-test, and even after consuming the drug. Likewise, those scoring lower on the pre-test tend to score lower on the post-test. To take this effect into account, the researchers employ a t-test using the differences between the pre-test values and the post-test values. Thus, only the gain or loss in values is compared. To visualize on how to solve this problem, let us have an example.
Hello everyone, good day. I am Farmera Didi Malzarte from BS Ed Math 3. Now, let us solve example number 1, which is about cholesterol levels. A dietitian wishes to see if a person's cholesterol level will change if the diet is supplemented by a certain mineral. 6 subjects were pre-tested and then they took the mineral supplement for 6-week period. Our results are shown in a table where cholesterol level is measured in milligrams per deciliter. The question is, can it be concluded that the cholesterol level has been changed at A equals 0.10? Assuming that the variable is approximately normally distributed. To solve the problem, let us solve first the example using the steps and lesson 2. Step 1. We have state the hypothesis and identify the claim. First, we have to state that our null hypothesis, which is the mean of the differences, is equal to 0, and the alternative hypothesis has the mean of the differences is not equal to 0. If the diet is effective, the before cholesterol levels should be different from the after levels. Hence, our alternative hypothesis, which is the mean of the differences is not equal to 0, is our claim. Now that step 1 is satisfied, let us proceed to step 2, which is to find the critical value. In finding the critical value, we have the formula. dF or degrees of freedom is equal to N or number of members of sample negative 1. In this case, dF equals 6 since there are 6 subjects being tested. Negative 1, which is constant. Then, we have dF equals 5 at A equals 0.10. The critical value are negative positive 2.015. Step 3. Let's compute the test value. To do step 3, let's first make a table. The values in the table are simply copied from the result shown in the previous table. Now that we have our table, let's answer the missing values in column A, which is the difference of x sub 1 and x sub 2. Now, we have 210 minus 190 equals 20. 235 minus 170 equals 65. 208 minus 210 equals negative 2. 190 minus 188 equals 2. 172 minus 173 equals negative 1. 244 minus 228 equals 16. Hence, we have the summation of D is equal to 100. Now that we have the summation of the differences, we can find the mean of the difference. So the formula for this is mean of the differences is equal to the summation of the differences divided by n, or number of members of sample. Then we have mean of the difference is equal to 100 divided by 6 is equal to 16.7. Now to complete the table, let's find D squared or column B. So in finding its value, it is simply squaring the value of column A. Then we have 20 squared equals 400. 65 squared equals 4,225. Negative 2 squared equals 4. 2 squared equals 4. Negative 1 squared equals 1. 16 squared equals 256. Hence, we have the summation of D squared is equal to 4,890. Then, the table is complete.
Once again, good day everyone. I am Mary Rose Balaba from BSED Math 3 and my task is to present the next part of the lesson. So after completing the table, we can now find the standard deviation of differences. We can use the formula. Standard deviation of the differences is equals to square root of n multiplied by summation of d squared minus summation of d raised to 2 over n multiplied by n minus 1. Now, let's substitute. We have n is equals to 6, summation of d squared is equals to 4,890, and summation of d is equals to 100. Now we have 6 multiplied by 4,890 is equals to 29,340, and 100 raised to 2 is equals to 10,000, and 6 multiplied by 6 minus 1 is equals to 6 multiplied by 5, 8 equals 30. Now we have 29,340 minus 10,000 is equals to 19,340. 19,340 divided by 30 is equals to 644.67. So the square root of 644.67 is equals to 25.39 or 25.4. Now let's find the test value. We can use the formula. Test value is equals to mean of differences minus mu sub d over standard deviation of the differences divided by the square root of n. Now let's substitute the values. We have mean of the differences is equals to 16.7, mu sub d is equals to 0, standard deviation of the differences is equals to 25.6, and n is equals to 6. Now we have 16.7 minus 0 over 25.4 divided by the square root of 6 is equals to 1.610. Then we can now proceed to step 4, which is make decision. The decision is not to reject the null hypothesis since the test value is 1.610. It is not in the non-critical region as shown in figure 9 to 7. Lastly, step 5, which is summarize the result. There is not enough evidence to support the claim that the mineral changes a person's cholesterol level.
Now, to continue the presentation, let's present the last part of the lesson, which is to solve for the confidence interval for the mean difference. In solving this problem, let's visualize it by answering example number 2. Find the 90% confidence interval for the data in example number 1. To solve this problem, all we need to do is to simply put this formula. Mean of the differences minus critical value multiplied by standard deviation differences over square root of n less than mu sub d less than mean of the differences plus critical value multiplied by standard deviation differences over square root of n. From this, let's just substitute the value in the formula. The values being asked here are what we solved in example number 1. Just find your previous answer to satisfy the formula. From our previous answer, we will have 16.7 minus 2.015 multiplied by 24.5 divided by square root of 6 less than mu sub d less than 16.7 plus 2.015 multiplied by 24.5 divided by square root of 6. Then we will have 16.7 minus 20.89 less than mu sub d less than 16.7 plus 20.89. Then we will have a grand total of negative 4.19 less than mu sub d less than 37.59. Hence, we have negative 4.19 is less than mu sub d and mu sub d is less than 37.59. Since 0 is contained in the interval, the decision is not to reject the null hypothesis, which is the null hypothesis is mu sub d is equal to 0. And that ends the presentation. Thank you and may God bless us all.